Is Davis Yanlova Gushino. I'm a roboticist and I have 4 years experience of programming robots. I've worked for various robotics companies in Europe, United States, and also San Francisco, and also Africa as well. So I'm glad to be at the final stage of RideScan API, RideScan Hackathon competition. So my project is a well, what is a my project is a warehouse perimeter robot that can navigate from to 4 different waypoints and be able to detect anomalies and also detect a risk score, and that by the RideScan API. And also that risk score is going to be published back to the mobile robot, telling the robot to stop if the risk score is high and there's a problem, probably like wheel slip, probably like angular velocity or increase in velocity. And also that signal, so that feedback is going to be sent back to my mobile phone and an XMX text telling me what the problem is. So the first thing first is the gazebo simulation, like you can see at the screen. It's a simulation environment and a physics environment used to simulate mobile robots. It can mobile robot like wheel legged robot, mobile robot like humanoid, mobile robots, robots like wheeled robots, AMRs, robot like drones, and different types of robots. So the reason why we're simulating it is to get the algorithm working before deploying it into hardware. So the gazebo simulation is a two-wheel differential drive robot that has a 2D lidar, has a caster wheel at the front, and also has a 2D DC motors. So what the robot is going to be doing is the robot is going to be navigating from one point to another in a 2D environment while checking if there is a risk being happening, and also anomalies by the robot, by the RideScan API, and telling the robot to stop if the anomalies is high, and also sending the feedback to my phone as an SMS text as well. So the yeah, so so I have an odometry and plotter graph. So what this does is that it tells me how the robot moves in the environment to detect if there's any anomalies. So the robot goes from point A, which is the waypoint 1, to waypoint 2, to waypoint 2, to waypoint 3. So during these waypoint, if there's any problem around the robots, if there's any problem around the robot, there's any risk around the robot, it sends it back to my robot uh, to tell it to stop, and also I have send it back to my SMS telling the reason why the problem happened. So I'll be launching the waypoint follower node with the robot to be going from one point to another, and also launching the safety monitor node. So what the safety monitor node is like is publishing to the RideScan API to retrieve that risk score, and if the risk score is high, it tells the robot to stop, while sending an SMS feedback to my mobile phone telling me the problem of the robot, while telling me the risk score and telling me that the robot has stopped, so that they can be able to detect and to troubleshoot the robot. Now, this scenario and this use case is very important because, for example, if a robotics engineer is in a different country and there's a client in America trying to check a problem with the robot, you can actually write an algorithm, or actually write a back end to be able to get the problem with the robot. And also, since you're not with where the robot is to monitor the robot, you can send that signal back to yourself or an email to tell you what the problem is, what the issue of the robot is, and also if the risk here is high as well. So this is so we have the gazebo simulation, we have the plotter node, and we also have the the feedback we're going to be sending back to my cell phone. So now the robot is navigating to the second side. You can see the robot navigating as well. So if probably there's an increase in velocity, a wheel slip, or really that the laser scan sensor is not working so well, or probably the odometry is not working so well, or probably there is the increase in speed while moving in angular velocity, the risk score will be high, and it's going to be sent making the robot stop and sending back the feedback to my cell phone as well. Yeah, so you can see the risk score is high. Now the robot is being stopped, and I'll be able to get an alert to my phone telling me that okay, this is what happened in the risk score. So what I did is that I wrote a back end node in Python that can subscribe to the velocity of the robot, subscribe to the risk score of the robot, and while publishing to the robot to tell the robot to stop when the risk score is being high, and that can be sent back to my phone. And also, you can also send this back to my email, giving you details of robots, of the risk of the robot so that we can be able to troubleshoot it to know what the problem is as well. Yeah. So that is my project. That's my brief description of my project, my full description of my project. So it's basically like a closed loop system. The robot spawning the robot into Gazebo, publishing to RideScan API to retrieve the robot. While if the robot if the risk score is high, due to the sense that probably increase in velocity, angular velocity has been increased, or probably there's a wheel slip, and that can be tell the robot to stop working so that we can go troubleshoot it, and that will send a feedback to my cell phone as details of what the robot is as well. So it's just a simple, I call it simple because here, so it's just like a full control loop system of how we can integrate a mobile robot, a wheeled robot to RideScan API. If there's a high risk score, it tells the robot to stop working. So probably engineers can go check it up, and also sending the feedback to my SMS to my phone as an SMS alert. Or I can also write an algorithm to send, or a feedback. Back end to send it back to my email as well. So this is the full description of my project, and I believe it's a very good use case for stage 3, and this is a closed loop system as well. Yeah, thank you, and have a nice day.